Here we go. Okay, let me just recap this real quick, run right through what we talked about. We're introducing hyperbolas here. Make sure to note the subtraction sign in between the two parts. That's going to be your key to indicating when you have an equation, when you have a hyperbola. Okay? Each formula is based on the transverse axis, meaning if your horizontal transverse axis, you're going to be using the first part, okay, up in here. If you have a vertical transverse axis, you're going to have this equation. Transverse axis, listen, is 2a long, just like the major axis was. It's still 2a long here. Conjugate axis, that's the other one. The conjugate axis and the transverse axis are perpendicular, just like the ellipse with the major and minor axes. Okay? The conjugate axis is 2b long. Okay, and we'll show you what those two things, how they apply in just a minute with a picture. Your relationship between your a, your b, and your c is the Pythagorean theorem here. C squared equals a squared plus b squared. Make sure to note that. If you're working with a hyperbola, yes, it is the Pythagorean theorem. If it's an ellipse, no, it's not. That was a squared equals b squared plus c squared. Okay? You have two asymptotes. Okay? For each one, you have the positive version and the negative version. So these two go with the horizontal transverse axis, and these two go with the vertical transverse axis. Now, hold your horses on that part of it, because you do not need to memorize that. I'll show you a way.
You don't need to memorize one.
You don't have to memorize the asymptote parts, but listen carefully. Do you agree, or will you tell me that can you graph a line? Can you write the equation of a line if I give you 2 points using y equals mx plus b? Can you still remember how to do that? Okay, if you can do that, then you can write the asymptotes just any way you want, all the time, just like that. And I'll show you how to find those 2 points. One of them is the center. One of them will be one of the points on your little box that we're going to draw. Okay? Any questions about the basics of the hyperbola equations? It's a little bit of information to memorize.
A little bit.
No. They can be anywhere. Okay? So, here's some pictures. If you've got your handout that I gave you, I hope you have that out kind of highlighting through that. You'll have the same sort of pictures. I want to talk about the top picture for a minute. Well, look over here. This gives you an idea of the conjugate and the transverse axis. Let me make sure to note this. The conjugate axis, this way, is not forever long. Okay? See that box that goes around right here? The conjugate axis actually goes from this point down to this point. The transverse axis goes from vertex to vertex.
Which one? Wait, the conjugate axis goes down to right?
The conjugate axis is this part. It's just the inside the box. I've drawn the line that goes through it. See that box? That box is created by knowing A, B, and the asymptotes. I'll show you how to create that. That's not a problem at all. Okay? But we have asymptotes, as you can see here. There's one. Here's the other. Your asymptotes basically create, if you had the asymptotes and you have your vertex, then you've got your shape of the hyperbola. If you come over to the other picture, you've got the center, which makes sense. It's the intersection of the conjugate axis and the transverse axis. We have the vertex, which is here and here. The vertex is A units away from the center. Okay, as you can see A there. If you go up to the top, notice you have this particular idea, but there's nothing labeled. We don't necessarily call these a name. They're not really a point on my graph, so we don't give it a name. You could talk about them as, co-vertices, but they're not really points. Okay, so don't label them. You can if you want to, but it's not part of your problem. The foci are outside. They're the farthest away in this case. Remember, if you cut that ellipse in half and flip it inside out, the foci would be on the outside, which they are here. And so they're C units away from a center. Right? So you have A, you have B, and then you have C. Questions about any of the parts of your hyperbola? We good? All right. I want you to look at this problem. What I want you to do is I want you to find the vertices and the foci. Take a second, and I want you to go through that and just... What are you going to do first? Good. Divide by 36. All right, let me just summarize. In order to find parts of a hyperbola, listen. In order to find the parts of a hyperbola, what we have to do is we have to have standard form in order to find A, B, C, H, and K. If I know the center and I know the length of my transverse and my conjugate axis, that gives me access to all the parts I need, A, B, C. Okay? Once I know A and B, I can find the third C. Or if I know A and C, I can find B. Whichever, you know two of them, you got all three. Once I have that, in order to find my vertices, because my transverse axis is horizontal here, I'm going to be adding, I'm changing the x coordinate. So I add H plus C, H plus A to get to the vertices, and minus A to get to the other vertex. To find the foci, I take H and I add C to get to the one focus. I subtract C to get to the other one. Since I'm at 0, 0 here, those two things were very easy to do because I was just adding and subtracting to 0. Doesn't always work out that simple, but that was easy for this problem. Okay? Remember, this is A squared plus B squared equals C squared. What is it for the ellipse?
C squared equals A squared minus C squared.
A squared equals B squared plus C squared, or C squared equals A squared minus B squared, whichever way you want to think about it. Just note it's not the Pythagorean theorem. So be careful. Okay? Let's try another one. This one's a little bit more involved. So find the equation and graph if you know the following information. Shh. I need everybody's undivided attention. Shh. If you get this part of it, then you really do understand a majority of what we're doing with the hyperbola, the ellipse, and the circles in terms of the graphing. So look at this one. On the screen, you can see I've graphed the vertices. So let me label those. So this is this is 2, 3. This is going to be 2, -1. In the center, right in between those, I have the center of my graph, which is going to be 2, 1. So automatically, I've got the center, HK. I found my vertices, which I really just gave to you automatically. Now, I've put some dots on the sides to represent the endpoints of the conjugate axis. I'm not really worried about their coordinates right now. But let's go ahead and let's write the equation of this thing. So is it going to be x squared or is it going to be y squared first?
Y squared.
Why is it y squared first?
Because it's up.
Because it's opening up and down. The transverse axis goes vertical. So it's going to be y minus 1 squared divided by what? What's A?
4.
Shh. What's A?
2.
A is 2.
So it's faux.
Okay? That's faux.
Okay.
So, hold on, look. Shh. That distance, that blue distance, that's the distance from the center. Shh. Listen. Center to vertex. In this particular shape, the relationship between what's larger or smaller doesn't exist. A can be the smallest number of all three of them. Okay? The only thing that's guaranteed is that C is the largest number of A and B. Okay? Where's B in my diagram? Where is it, though?
On the sides.
It's on the sides. 2 dots equals y.
It's here. Right? So if that's B,
It's 3, which is 9.
this is A. So we go back over here. This is going to be 4 minus y or x.
Y. X.
X. Where are you getting all the southern accents from? All right, squared over 9 equals 1. Shh. We found A, we found B, we found the center of my hyperbola, and we wrote the equation from it. Okay, so the next thing I need to do is to draw the box that kind of bounds these pieces. Can you see the box?
Yeah.
I've labeled the midpoints of all the boxes so far. So what I can do is just draw that box in kind of like this.
Just like
The points I've given you, the vertices, and the endpoints of the conjugate axis act as midpoints of the sides of my little rectangle. And so you draw that in. Now what's important is that I get a few points. I get this point, this point, this point, and this point. Remember I told you that we need to find the equation of the asymptotes sometimes?
no.
Can you give me the coordinate of this particular point right here? What's that? What's the coordinate for this point?
5, 3.
Yeah, it's just, we count out. We know this is 5. We know that this is 3. So it's just going to be 5, 3. So if I know that point, listen, if I know this point and I know the center, can you write the equation for the asymptote?
Yes.
Okay, so, and I'm not going to do that because that's easy enough. I can do that for any of my asymptotes. If I find one of the corners and the center for each asymptote, I've got it. Okay? The asymptote slopes are just reciprocals of one another. So if one is 2/3, the other slope is going to be 3/2. Okay? So here's my asymptote. Here's the other asymptote. And you see them drawn in just through the corners of that box. Listen carefully. I need the box in order to draw the hyperbola. Is this hyperbola going to be wide or skinny based on my drawing?
Wide.
It's going to be very wide. So we're going to go ahead and draw that in. Shh, quiet. Okay, so there's your hyperbola. Questions? So here's the solution. You can see the asymptotes, the equation, the vertices and the foci, and a little bit of the graph on the screen. Make sure that you know how to do those things. So your homework tonight is going to be from page 663, 3 through 51, multiples of 3. This is exactly what we did in class today. It's graphing a little bit. Sometimes I give you a part of it, and you tell me the equation. Sometimes I give you the equation and tell me to find the graph. Sometimes I ask you to complete the square and give me the standard form of the equation. Make sure you practice those tonight, and we'll talk about them tomorrow.